Hello all, this is Trusha Patel. Welcome to the part 4 of syntax directed translation. We will look at the few more example of SDD. Here we will see that for the same grammar, if we are changing the semantic rule, how it will affect on the output. So we'll form the SDD for binary count. So to form the grammar for this, as we know that in binary we have only two possible bit, either 0 or 1. So our production will be B gives 0 and B gives 1. Now the binary number can be formed from the sequence of those bits. So on top of that we'll be having a production like n gives s, where n stands for number and s stands for sequence. And sequence can be a single bit, so s gives b, or at the end of this sequence I will attach 111 bit, then it will increase the length of my sequence. So I will also have one production, that is S gives SB. So at the end of the bit sequence, if I add a bit, that will again form a new sequence. So my production is number gives sequence, sequence gives sequence followed by bit, or sequence give bit, then next bit gives 0 and bit gives 1. Now I want to form the SDD which will count the number of 1 present in my binary number. So I have to attach the semantic rules to this grammar. Now as I want to count only number of ones, for the production B gives 0, I will use the attribute count. So B dot count will remain 0 and B dot count is equals to 1 in case of the production B gives 1. Then whatever the count of the B will be transferred to the count of the sequence. Then count of the sequence equals to the previous count of the sequence plus the count of the bit. And finally, the count of the sequence will be transferred to the count of the number. Now, using the same grammar, if I will implement a SDD which will count the number of 0, in the entire semantic rule there will be a small change. B dot count is equals to 1 for the production B gives 0, while the B dot count is equals to 0 for the production B gives 1. So we are just incrementing the counter whenever the 0 is encountered and not incrementing the counter or keeping counter as 0 if 1 is encountered. And the third possibility is if we want to count all the number of bits which are available in our binary number. So in that case, b dot count is equals to 1 for the both, either it is 0 bit or 1 bit. So b gives 0 and b gives 1. Both the productions are having the same semantic rule, that b dot count is equals to 1. So now you can see that we are having only one grammar, but if I am changing the semantic rule, my SDD is changing. For the first set of semantic rule, my SDD will only count the number of ones present. For the second semantic rule, it will count only number of zeros which are present. And for the third set of semantic rule, it will count all the number of bits which are present in my number. Thank you. We'll be back with the part 5.